Mid-February 1943. Sidi Bou Zid, Tunisia. North Africa's desert wind carried sand across scarred battlefield terrain where American and German forces had clashed days earlier. Among the wreckage and abandoned equipment, a single M4A1 Sherman tank sat motionless, its white American star still visible beneath hastily painted German markings. This captured tank, designated War Daddy 2 by its former crew, would soon embark on a journey that would expose truths German engineers desperately needed to ignore. What began as routine technical examination of enemy equipment would trigger a crisis that echoed through German armored vehicle development for the remainder of the war. The mathematics of mechanized warfare were about to be rewritten, not through superior firepower or thicker armor plating, but through something German tank designers had consistently dismissed as secondary: automotive reliability that simply refused to break under conditions that destroyed their own vehicles. The captured Sherman bore serial number USA 3067641, built by Lima Locomotive Works in Ohio and belonging to Company G, 1st Armored Regiment, 1st Armored Division. German reconnaissance personnel drove this 30-ton American tank 350 kilometers across North African terrain to the coastal port of Sfax, a journey requiring 4.5 days of continuous operation. Every kilometer revealed characteristics that contradicted German assumptions about American industrial capability and engineering priorities. The Continental R975 radial engine maintained consistent power delivery without overheating despite brutal desert heat. The transmission shifted smoothly through all 5 forward gears without protest or mechanical complaint. The final drive assemblies transmitted power to the tracks without the grinding noises, excessive heat, or catastrophic failures German crews had learned to expect from their own vehicles during extended movements. German tank operators, thoroughly accustomed to frequent maintenance stops even during short tactical movements, observed with growing unease as this enemy vehicle simply functioned correctly, kilometer after kilometer, without requiring intervention from mechanics or specialized tools. At Sfax port, War Daddy 2 was loaded aboard a cargo vessel bound for Germany. The Army Weapons Office had issued explicit instructions that this intact, operational American tank must reach the testing facility at Kummersdorf proving ground without damage. German military intelligence had received fragmentary reports about American tank production capacity, but seeing physical evidence made abstract statistics disturbingly real in ways numbers on intelligence reports never could. This Sherman represented mass production engineering at scales Germany could not match, built using automotive manufacturing principles German industry had failed to master despite decades of theoretical knowledge. As the transport ship steamed northward across the Mediterranean toward European ports, Wehrmacht engineers prepared comprehensive testing protocols that would reveal uncomfortable truths about German limitations and American capabilities that propaganda had carefully obscured. Spring 1943. Kummersdorf Proving Ground, Brandenburg, Germany. War Daddy 2 rolled off the transport railcar bearing the designation Versuchsfahrzeug 259 and German military license plate WH058941. Test engineers had already stenciled precise armor thickness measurements and angle notations across every surface of the captured tank, marking it with meticulous technical annotations for their exhaustive evaluation program. The German Army Proving Ground at Kummersdorf, located 25 kilometers south of Berlin, served as the primary testing facility for both domestically produced and captured Allied military equipment. Here, systematic engineers measured, tested, analyzed, and documented everything from track tension specifications to transmission efficiency ratings, recording their findings in exhaustive technical reports that circulated through Wehrmacht commands and armaments ministry offices. The American Sherman tank was about to undergo the most comprehensive automotive examination German engineering could devise, subjected to testing protocols designed to expose every weakness and design flaw. German test engineers conducted initial inspection with specialist teams from multiple technical branches converging on the captured vehicle. They photographed every component from dozens of angles using precision cameras, measured every mechanical clearance with calibrated instruments, and documented construction techniques that appeared impossibly straightforward compared to complex German manufacturing methods requiring specialized tooling and highly trained machinists. The transmission immediately captured attention from powertrain specialists who disassembled it for detailed examination. Where German tanks employed straight-cut transmission gears requiring extremely precise tolerances and constant maintenance attention, the Sherman used herringbone-cut gear profiles that distributed mechanical stress across multiple gear teeth simultaneously, providing exceptional durability with minimal precision manufacturing requirements. This gear-cutting technology, standard in American automotive manufacturing since the 1930s, allowed mass production of reliable transmissions using semi-skilled labor and general-purpose machine tools. German engineers had considered herringbone gears excessively difficult to manufacture at scale given their industrial capabilities and available workforce training. The Americans had been producing them by the thousands monthly without apparent difficulty. Systematic testing commenced with basic automotive trials designed to stress every mechanical system under carefully controlled conditions that simulated battlefield environments. Engineers drove War Daddy 2 through obstacle courses designed to replicate combat terrain, meticulously measuring fuel consumption rates, monitoring engine operating temperatures, recording transmission behavior under varying mechanical loads and diverse terrain conditions. After each trial sequence, they systematically disassembled components to microscopically examine wear patterns, searching for evidence of mechanical stress, inadequate lubrication, or fundamental design weaknesses that would cause eventual failure under sustained operational use. The accumulated results contradicted everything German tank doctrine had accepted as necessary engineering trade-offs between combat performance and mechanical reliability. The Sherman performed adequately across every measured category and excelled dramatically in the single metric where German tanks consistently, catastrophically failed, operational endurance without requiring expert maintenance intervention or specialized replacement parts. The powertrain examination revealed fundamental design philosophy differences explaining much about contrasting American versus German engineering approaches to armored vehicle development. The Sherman transmission featured 5 forward speeds plus 1 reverse gear, with synchronized shifting mechanisms in gears 2 through 5 that completely eliminated the need for complex double-clutching techniques during normal driving operations. This single design choice made the tank nearly as simple to operate as civilian automobiles, requiring only minimal specialized training for drivers who possessed basic automotive knowledge from civilian experience. German tank operators, by sharp contrast, spent considerable training time mastering intricate double-clutching techniques and careful throttle management procedures necessary to avoid catastrophically damaging their vehicle's temperamental transmissions during gear changes. The Sherman's fundamental design philosophy accepted that ordinary soldiers with limited technical backgrounds would operate these combat vehicles under stressful battlefield conditions, while German designs assumed highly trained specialists with extensive mechanical education would always be available to maintain and operate their sophisticated equipment. June 6 and 7, 1943. Hillersleben Artillery Proving Range. Reichsminister Albert Speer arrived to personally preside over a major armament demonstration conference attended by senior leaders from Germany's armaments industry and high-ranking Wehrmacht officers. The demonstration program included comparative hill climbing capability trials featuring German and captured Allied tanks performing identical maneuvers on standardized test courses. War Daddy 2 sat alongside Germany's latest tank designs, including a freshly manufactured Panther Ausführung D medium tank and a Ferdinand tank destroyer representing Germany's most technically advanced armored fighting vehicle incorporating revolutionary electric transmission technology. Speer, bearing ultimate responsibility for German armaments production and personally accountable to Adolf Hitler for industrial output results, urgently needed to understand what American industry could realistically produce and how current German designs measured against enemy equipment his forces would encounter across multiple combat fronts. This carefully orchestrated demonstration would provide answers that neither Speer nor German tank designers wanted to publicly acknowledge. The Sherman climbed the designated test slope smoothly and confidently. Its synchronized manual transmission shifted through 5 forward gears without hesitation or grinding noises. The Continental radial engine maintained absolutely consistent power delivery throughout the steep ascent, never faltering or losing momentum. The driver handled the American vehicle with obvious confidence and ease, demonstrating operational simplicity that would become a defining Sherman characteristic appreciated by crews worldwide. The German Panther followed, its substantially more powerful 700 horsepower Maybach HL230 engine allowing it to match the Sherman's climbing performance, but only barely, and with considerably greater difficulty requiring expert throttle control and precise gear selection timing. The massive Ferdinand tank destroyer, weighing 65 tons and incorporating technically sophisticated electric transmission systems that represented cutting-edge German engineering, stalled catastrophically partway up the test incline, its complex drivetrain unable to sustain power delivery under load. Speer watched in visible discomfort as recovery crews struggled desperately to restart the immobilized vehicle, this deeply embarrassing mechanical failure occurring before dozens of senior military officers and industrial ministry leaders whose confidence in German technical superiority was visibly shaken by the public demonstration of fundamental design inadequacy. The written public assessment appeared in Das Reich newspaper on June 27, 1943, carefully worded for propaganda purposes to avoid appearing overtly defeatist while acknowledging undeniable American achievements. The article described the Sherman as representing one of the special accomplishments of North American industrial laboratories and called it quite a praiseworthy product of the North American steel and automotive industries. The piece specifically noted that the first characteristics to attract technical attention were serial production quality and fulfillment of what the article termed the almost arrogant requirements of the North American automobile manufacturing industry regarding reliability and ease of operation. The article mentioned the gyroscopically stabilized main gun as the first successful attempt of its kind ever implemented in production tanks anywhere globally, grudgingly acknowledging genuine American innovation in fire control technology. These carefully constructed public statements, meticulously edited for domestic consumption, nevertheless barely concealed the private alarm spreading rapidly through German tank development departments and armaments ministry offices. American tanks were not merely adequate emergency equipment produced by inexperienced manufacturers. They were fundamentally superior engineered products for sustained field operations under combat conditions, built by an industry with decades more practical experience than German tank manufacturers possessed. Back at Kummersdorf, methodical systematic testing continued relentlessly through summer and autumn of 1943, accumulating comprehensive data that painted an increasingly uncomfortable picture. Engineers measured the Sherman's operational range through extended endurance trials that pushed the vehicle to its absolute mechanical limits, documenting operational ranges consistently exceeding 2,000 kilometers before requiring major component overhauls or replacement parts, roughly 4 times the distance early production model Panthers could achieve under comparable field conditions before experiencing catastrophic mechanical failures. They measured transmission mechanical efficiency that substantially exceeded any German tank design, with power losses through the complete drivetrain significantly lower than supposedly superior German systems despite simpler construction methods. They exhaustively examined the synchronized manual transmission that made gear changing smooth and simple for operators, requiring neither the complex double-clutching procedures nor the careful engine speed matching that German transmissions absolutely demanded to avoid immediate damage. The final drive assemblies presented yet another engineering revelation that fundamentally challenged German design assumptions and manufacturing priorities. German Panther tanks employed final drive reduction gear systems inherited directly from Tiger heavy tank design specifications, a configuration repeatedly proving prone to catastrophic failure under sustained operational stress. The design utilized straight-cut reduction gears housed in casings that proved structurally inadequate for the severe mechanical loads imposed by the 45-ton vehicle during cross-country movement. German field mechanics serving in North African and Eastern Front theaters had filed increasingly desperate reports documenting final drive assembly breakdowns that forced complete vehicle abandonment after relatively short movement distances, sometimes less than 100 kilometers of operation. The Sherman's final drive assemblies, manufactured using identical herringbone gear design principles as the main transmission, rarely failed even under sustained combat conditions and terrain types that would quickly destroy comparable German components through stress fractures and bearing failures. By late 1943, Kummersdorf had systematically accumulated sufficient empirical data to produce comprehensive internal technical reports that circulated through Wehrmacht engineering branches and armaments ministry evaluation departments. These confidential documents, intended exclusively for senior Wehrmacht technical officers and armaments production officials, painted an increasingly sobering comparative picture of relative industrial capabilities. The Sherman conclusively demonstrated American automotive engineering maturity that Germany fundamentally lacked despite possessing extensive theoretical knowledge and scientific expertise within its technical universities and research institutions. American mass production manufacturing techniques successfully employed dimensional tolerances that would be dismissed as unacceptably sloppy by German precision manufacturing standards, yet consistently resulted in more mechanically reliable combat vehicles that functioned better under actual field conditions than German equipment built to supposedly superior specifications. True parts interchangeability meant field repair operations could be successfully accomplished using basic general-purpose tools and minimal specialized technical training, while German vehicles routinely required factory-level precision equipment and extensively trained specialists for many common repair procedures. Internal German engineering assessment documents meticulously documented observations about fundamental American industrial advantages extending far beyond simple production volume numbers. American automotive engineering philosophy reflected decades of extensive civilian industry practical experience that Germany had never developed at remotely comparable industrial scale or technical sophistication. Before the war's outbreak, the United States had achieved widespread private automobile ownership with motor vehicles commonplace among ordinary citizens across all economic and social classes. Germany possessed far more limited civilian automotive industry experience, with private cars remaining luxury items accessible only to wealthy individuals and Nazi Party elite members. The celebrated Volkswagen program, prominently promised to German workers since 1934 as proof of National Socialist commitment to ordinary citizens, had delivered fewer than 1,000 actual civilian vehicles by 1939 when war began. This vast fundamental difference in automotive industry maturity and practical manufacturing experience translated directly into contrasting tank design philosophies with profound operational consequences. Americans designed and built tanks that mechanics possessing only civilian automotive repair training could successfully maintain using practical skills and knowledge they already possessed from peacetime employment. Germans built tanks requiring specialist military training and constant expert attention from technical personnel with years of specific military mechanical education and access to specialized tools. Additional captured Sherman tanks arrived steadily at Kummersdorf throughout 1943 and 1944, including vehicles taken from British Commonwealth armored units in Italian campaigns and Soviet forces on Eastern Front battlefields. Each captured vehicle underwent similar comprehensive testing protocols, systematically building an extensive database of American tank capabilities across different production variants and manufacturing periods. The British had retrofitted some Shermans with their excellent 17-pounder anti-tank gun, creating the Firefly variant that effectively addressed the Sherman's primary combat weakness in main armament firepower against heavy German armor. German engineers examined these British-modified tanks with particular technical interest, carefully noting how the Sherman's generously sized turret ring diameter readily accommodated the significantly larger gun with minimal structural modification or vehicle redesign. The successful Firefly conversion demonstrated substantial growth potential intelligently built into the original American design that German engineers had never considered when initially specifying their vehicles for immediate combat requirements. The Panther, rushed into premature production to desperately counter superior Soviet T-34 tanks, possessed absolutely no capacity for significant armament upgrades without complete turret and vehicle redesign requiring extensive retooling. By December 1943, the accumulated pattern had become completely undeniable to any objective observer honestly examining the comprehensive empirical data. Sherman diesel variant engine service lifespan consistently exceeded 3,000 kilometers under proper maintenance procedures. Panther engine service lifespan barely reached 1,000 kilometers even after multiple design improvements had addressed the worst early catastrophic problems that had plagued initial production vehicles. German official reports from March 1944 proudly documented that improved Panther engines had successfully achieved service life of 700 to 1,000 kilometers, presented internally as a significant engineering success and proof of problem resolution. This celebrated improvement had merely brought Panther engine reliability to roughly one-third of Sherman diesel engine capability, a comparison carefully obscured in official reports. Sherman transmissions required only minimal routine maintenance between complete overhauls, with robust synchronized gears making driver error substantially less likely to cause immediate damage. Panther transmissions demanded constant expert attention and frequent repair interventions, with third-gear failures so commonplace that experienced drivers learned to skip directly from second gear to fourth gear to deliberately avoid using the notoriously problematic third-gear ratio entirely. March 1944 brought carefully worded official reports from General Heinz Guderian, Inspector General of Panzer Troops, noting in formal military communications that systematic improvements to Panther mechanical reliability had finally achieved what he carefully termed acceptable operational standards by early 1944. Engine service life had reached 700 to 1,000 kilometers, and persistent final drive problems had been largely resolved through incremental design modifications and improved manufacturing quality control processes. This supposed improvement, presented as significant success in German military communications and proof of engineering competence, had merely brought Panther reliability to operational levels that Sherman tanks had routinely exceeded from initial production in 1942. The German Army leadership celebrated finally reaching basic standards that American tanks had consistently surpassed from the very beginning, inadvertently highlighting how dramatically far behind German armored vehicle development had fallen compared to American automotive engineering capabilities. Reports from actual Panzer regiments operating various captured American vehicles noted that Sherman operators could focus mental attention on tactical considerations and combat effectiveness planning, while Panther and Tiger crews constantly worried about successfully reaching the battlefield without mechanical breakdown or completing assigned missions before inevitable mechanical failure immobilized their vehicles far from recovery support. The 10th SS Panzer Division successfully captured 12 M4A3 Sherman tanks at Hatten-Rittershofen in January 1945 during Operation Nordwind. These particular tanks had belonged to the American 43rd Tank Battalion and were captured completely intact when their crews hastily abandoned them during the initial German assault. The 12 captured Shermans were immediately formed into the 13th Company of the 10th SS Panzer Regiment and actively served in direct combat operations for the war's remainder. These American tanks served primarily as reconnaissance vehicles and mobile tactical reserves, specific roles that absolutely required sustained movement without maintenance stops and utterly reliable mechanical performance under stress. German commanders explicitly recognized what years of Kummersdorf testing had conclusively proven: American tanks could be confidently relied upon to function correctly when needed most. This fundamental dependability, far more than firepower or armor protection specifications, ultimately determined practical tactical utility during the final desperate months of the war. January 1944 brought significantly expanded testing programs as Wehrmacht forces retreated across multiple fronts and additional captured equipment reached Kummersdorf from various theaters. Engineers systematically examined the M4A1 variant with Continental R975 radial gasoline engine, meticulously documenting its specific characteristics and comparing performance to other variants. They tested the M4A2 variant with twin General Motors 6046 diesel engines, carefully noting its superior fuel efficiency and different operating characteristics compared to gasoline-powered versions. They evaluated the M4A3 variant with Ford GAA V8 gasoline engine, which American tank crews consistently rated as the best Sherman powerplant for reliability and performance. Every tested variant demonstrated identical fundamental characteristics, excellent automotive reliability directly derived from sound engineering principles and quality manufacturing processes. The remarkable consistency across variants from different manufacturers deeply impressed German engineers who were thoroughly accustomed to significant quality variations between different factories producing nominally identical vehicles to the same specifications. January 23, 1945 brought the final devastating official admission of comprehensive German automotive engineering failure. A meeting of the Panzer Commission produced a confidential report documenting catastrophic final drive assembly failures across all German tank types currently in production and frontline service. The document's findings were absolutely devastating to any remaining confidence in German tank design competence. Prior to the 1945 Eastern Offensive operations, there were 500 defective final drive assemblies in the Panzer IV medium tank, 370 defective units in the Panther, and approximately 100 failures in the Tiger heavy tank. Additionally, roughly 200 final drive failures had been officially reported in the Hetzer tank destroyer design based on the Czech 38-ton chassis. General Wolfgang Domail, General Lieutenant and Chief of Staff to the Inspector General of Panzer Troops serving directly under Guderian, explained the severe operational impact in devastatingly stark terms that admitted complete systemic failure. In such circumstances, orderly utilization of tanks was simply impossible. The troops completely lost confidence in their vehicles and in some desperate situations abandoned perfectly intact vehicles just because of final drive problems, rationally fearing they would become stranded and captured. Kummersdorf testing facility frantically prepared for emergency evacuation in early 1945 as Soviet forces advanced relentlessly and inexorably toward Berlin through collapsing German defensive lines. Engineers desperately packed years of accumulated testing data and hastily shipped critical documentation to facilities located farther west, hoping to preserve invaluable technical intelligence for eventual post-war analysis. Some of the various captured tanks, including at least 2 operational Sherman tanks, were pressed into improvised combat service with desperate units defending the final approaches to Berlin against overwhelming Soviet forces. These vehicles fought alongside remaining German designs in the final apocalyptic battles, providing one last direct comparison under actual combat conditions. The American Shermans continued operating reliably until finally destroyed by concentrated enemy fire or deliberately abandoned when fuel supplies were completely exhausted. The German tanks, including surviving Panthers and the few remaining operational Tigers, broke down from predictable mechanical failures at rates that shocked even thoroughly experienced crews completely accustomed to poor reliability. Post-war analysis conducted by American and British technical intelligence organizations systematically confirmed what exhaustive German testing at Kummersdorf had revealed years earlier. Methodical examination of destroyed German tanks consistently found mechanical failures equally as common as direct combat damage as causes of total vehicle loss. Final drive assemblies broken from excessive mechanical stress, transmissions seized solid from inadequate lubrication or operator error, engines completely burned out from chronic overheating or oil system starvation. The German obsession with individual vehicle technical superiority and impressive specification statistics had completely blinded them to the critical importance of reliability and maintainability. They built tanks that no conscript mechanic could successfully maintain without extensive specialized training, powered by temperamental engines demanding constant expert attention from highly skilled technicians, supported by an impossibly complex logistics system that collapsed under accumulated strain of supplying countless unique parts to scattered units. The profound lessons learned through systematic testing at Kummersdorf directly influenced German tank design thinking in the post-war Bundeswehr of West Germany. When the Federal Republic began developing the Leopard 1 main battle tank during the 1950s, designers consciously emphasized reliability and maintainability over pure performance specifications. They carefully studied American automotive engineering principles and deliberately applied them to military vehicle development. The resulting Leopard 1 tank successfully incorporated many design philosophies that had made the Sherman so successful. Robust powertrain with substantial design margins. Easy maintenance requiring minimal specialized tools. Standardized components enabling rapid field repairs. Growth potential allowing future upgrades without complete redesign. The Leopard 1 became one of the most successful tank designs of the Cold War era, serving with numerous armies and remaining in continuous production for decades. War Daddy 2, that single Sherman tank captured in Tunisia and tested exhaustively at Kummersdorf for months, told the entire story through its mechanical reliability and consistent performance. Every kilometer it drove without failure was evidence that German tank design had taken a fundamentally wrong path by prioritizing specifications over reliability. Every test that demonstrated American automotive excellence was proof that industrial maturity and practical manufacturing experience mattered more than theoretical performance calculations. Every comparison between Sherman and German tank reliability proved that Americans had solved problems German engineers never realized they needed to solve.